All right, so now let's look at example 2 right down here. Refer to example 1 concerning the mean satisfaction levels of customers of 2 competing cable television companies. So that's that information we had right up here. Test at the 1% level of significance whether the data provides sufficient evidence to conclude that company 1 has a higher mean satisfaction rate than does company 2. Use the critical value approach. Okay, so let's go ahead then and start. I've written down our test statistic for 2 large samples, and we'll deal with that in a minute. But first, let's get our null hypothesis. And in the case of our null hypothesis, we're going to say mu1 minus mu2. So the difference, now, our difference is going to be that our null hypothesis is going to be that these two have the same satisfaction levels. And if they're the same and we subtracted these two, we would get 0. All right, so if their satisfaction levels are the same and we subtract the two means, we would get 0. On the other hand, if this first group has a higher satisfaction rating than the second group, then when we subtract the first mean minus the second mean, it will be greater than 0. All right, so we've got our 2 hypotheses. Let's deal with our significance level. Alpha is 0.01. Now, since this is a right-tailed test, remember we've got to subtract that from 1. Oops. And that's going to give us 0.99. We want to put 0.99 into Excel and see what we get. And remember, we're looking at a right-tailed test, so we just want the one result that we get. All right, so equal norm.s.inv, and it was 0.99, and that gives us 2.326. So Z is 2.326. All right, so that's our critical value. All right, now that we've got our critical value, we know it's a right-tailed test. Anything to the right of 2.326 will be in the rejection region. Let's now do our test statistic. Now here's where I want to go up to this formula and use it to get my test statistic. All right, so x bar 1 minus x bar 2. Now let's save ourselves a little bit of work. In the prior example, we did x bar 1 minus x bar 2 right over here, and it was 0.27. So on the top, I'm going to have 0.27 minus this d sub 0 is always whatever we put in our null. And generally, it's going to be 0. All right, so the difference between those two is 0. Now let's go to the bottom. We want the square root of, and here's kind of the cool thing. When we were doing this confidence interval in example 1, you'll notice that this part right here, this square root of this, is really the bottom of our test statistic, and I did it without including this 2.576. So that answer we can go back here and get. The square root of the denominator right here is actually, and I really don't need to write that square root right there, it's actually 0.047502.818. We don't want to double our work. So on the top we have 0.27, on the bottom we have 0.047502.818. Let's divide that out. That gives us 5.684, and that is certainly to the right of 2.326. So it's in the rejection region. Which means we reject the null. And let's make our final statement. There is significant evidence And here we'll state alpha equal 0.01 to reject the null hypothesis. It appears that company 1, oops, I'm running off the page here. Let me pull this over for you. That company 1 has higher satisfaction rates, or scores, I guess, than company 2. All right, now while we're here, let's do the p-value approach to this same problem. Recall, with the p-value approach, we wouldn't have found the critical value right here. We would have skipped that step and gone straight to 5.684 as our test statistic, and we would use Excel to look up that p-value. Now remember, this is a right-tailed test, so once we look up our p-value, or once we look up the probability on Excel, our p-value is going to be 1 minus that probability. So let's put 5.684 in here. We'll have equal norm.s dist 5. What was it again? 684. 5.684. The word true. And it is almost 1, and so in fact it's very close to 1, so it's saying that it's 1. Now remember though, I said we had to subtract our p-value from 1, or rather our probability from 1, so our p-value, as far as Excel can actually figure out, is so small that it rounds to 0. Now it's not really 0, but for the sake of our statement, it's so small it might as well be 0. P-value equal to 4 decimal places. 0, 0, 0, 0. All right, so still the p-value is tiny, much smaller than alpha. Our rejection remains the same. Only thing that's different is we put our p-value down here. If we had a little bit more sensitive software than Excel, we'd be able to state that p-value up to probably 8 decimal places or something, what it really is.